Let's start by reviewing how to solve equations. We're going to fill in the blanks at the top. We've got an equation, first vocabulary word. An equation is a mathematical statement that shows that two expressions are equal. An equation is always going to have that equal sign. Each side of that is some mathematical expression. Second blank, a solution. A solution is any value that makes our equation true when it's substituted in for our variable. Of course, with equations, once you finish solving, you can take your solution, plug it back into the original equation to show that the equation is equal to both sides. The properties of equality state that you can perform the same operation on both sides of an equation without affecting the solution. So on the left side of our table here, we've got our classic properties of equality, starting with the addition property of equality. It says that if I have A equals B, if A and B are the exact same value, they are equal, then I can actually have A plus C, and it would still be equal to B plus C. I could add to both sides and keep my equation balanced. The second property, subtraction property of equality, same thing. If A is equal to B, then I could subtract C on both sides and still have a balanced equation where the values are the same on both sides of that equal sign. Multiplication property of equality, I could multiply both sides by C. And then division, you guessed it. I could divide both sides by C on my equation and it would remain balanced as long as we're not dividing by 0, because that's not okay in mathematics. On the right side, we've got some other properties of equality. The first one being the symmetric property. You've seen this, you just maybe have never heard the actual term for it. It says if I have A equals B, I can flip that equation over and rewrite it as B equals A. Sometimes when we have a really tricky equation and we want to flip it over so we feel more comfortable with it, we are allowed to do that. Or you solve it and it's 3 equals X and you want to write your final answer as X equals 3. Same idea. That's called the symmetric property of equality. Commutative property of addition and multiplication, not subtraction, not division. Commutative says that we can rearrange them. A plus B is the same as B plus A. So I can rearrange, and the same is true with multiplication. The associative property, you've got those grouping symbols. This is where I can regroup items in addition and multiplication. And lastly, distributive property. You are familiar with this one. You can distribute that term on the outside across your parentheses, resulting in A times B plus A times C. So let's begin by walking through some examples, getting warmed up. All of these solve for X. Number 1, 17 plus 5X equals negative 23. We want to isolate our variables, starting by removing the extra term. So I'm trying to get to X, but let's get rid of this extra term 17. That's a positive 17. You need to subtract 17 away from both sides. My left side leaves me with 5X, negative 23 minus 17 is going to give us negative 40. Divide the coefficient of 5 away because 5 and X right there, they're bumped up and multiplying. So we're going to divide that away. 5 divided by 5 is 1X or just X. Negative 40 divided by 5, negative 8. Final answer. You could take negative 8, like we mentioned before, is our solution. Plug it back in for X in the original equation. 17 plus 5 times negative 8 should yield negative 23. Second example, we're solving for X. Get rid of your extra term on that same side. Let's add 32 to make that a 0. That's negative 32, adding 32 cancels it out. We're going to use that addition property of equality, adding to both sides. Negative 59 plus 32 is negative 27 equals, we're still left with negative 3X. Isolate that X by dividing away that negative 3, just like we did in the last problem. Divide both sides. Negative 27 divided by negative 3 is positive 9 equals X. You could use the symmetric property, flip that over, and write your final answer as X equals 9, and it would mean the same thing. Number 3, 48 equals 45 minus X over 6. So again, still trying to isolate X. Let's get rid of the 45, which is positive. Subtract that away. Now, sometimes I have students that are used to seeing a subtraction expression and they want to add. Well, we're trying to get rid of a positive 45. So we are subtracting 45 on both sides here. 48 minus 45 on the left side gives us 3 equals, this is a negative x over 6. Now, you might know I could rewrite this as negative 1/6 times x. There's an understood 1 in front of that x, so maybe you want to rewrite it that way. But we're going to get rid of that coefficient of a negative 1/6, the division of a negative 6, however you view it. Let's multiply both sides by negative 6. Getting rid of that. Now, maybe you're still scratching your head. Wait, what? What is happening? It was negative 1/6 times x. What are you doing? Now, remember, if you wanted to divide that coefficient away, we don't divide fractions by fractions. It's really bad mathematics. Instead, we multiply by the reciprocal, right? So that's that negative 6 that I'm getting. So we're multiplying both sides by negative 6. Negative 6 times 3 on the left side gives us negative 18 equals, the only thing left over here is that x. So negative 18 equals x is our final answer and our solution. Number 4, x divided by 7 minus 1 equals 8. Getting rid of that extra term, add 1 to both sides first. X divided by 7 equals 9. This one's pretty straightforward. X is being divided by 7, so let's multiply both sides by 7. 9 times 7 is 63. X equals 63. So you might have some big solutions, but if I plug that 63 back into the original problem, it makes sense. 63 divided by 7 is 9, minus 1 is 8. So it does make sense back in our original problem. Number 5. Now, we did talk about the distributive property a second ago, so you might be really tempted to distribute, and you can if you want to here. Let's do that strategy first. On number 5, we have 2 times the quantity of 3x minus 8 equals 8. So if I distribute across, I'm going to get 6x minus 16 equals 8. And then you can continue to solve, get rid of that extra term, the minus 16, by adding 16 to both sides. 8 plus 16 on the right is going to give you 24. Divide both sides by that coefficient of 6. X equals 4. That's one way you can do it. I want to show you another way just in case you see it worked out differently on Delta Math. So we started with 2 times the quantity 3x minus 8 equals 8. And I said that it is 2 times the quantity of. So those are multiplying, right? You could start off by dividing away that 2 if you wanted to and have 3x minus 8 equals 4. Add 8 to both sides, solve the two-step equation from there. So let's see, 4 plus 8 is 12. Divide both sides by 3. Guess what answer I'm getting? The same, x equals 4. Let me show that these problems are separate. And there you have it. So 2 different methods you could use to solve number 5. You can distribute across and then solve, or eliminate the whole distributive issue, divide away that term in front, and continue to solve after that, whichever method you prefer. In the next section, we're going to look at solving equations with variables on both sides. Always begin by isolating your variable. Always do this first. This is how I always taught it for 8th grade math students. This is what I always encourage, because if you recall from 8th grade math, sometimes our variables eliminate and we have to use those constant values to see if we have many solutions, no solutions kind of scenario. So you always want to take care of those variables first. Do that for me and we'll have an easy time solving. Let's look at number 6. 6x plus 3 equals 9x minus 12. Always get rid of the variable first. And then my choice is I always get rid of the smaller variable first. That way I'm not dealing with negatives. So 6x is definitely smaller. So let's subtract that away because it's positive 6x. And I'm subtracting on both sides, that subtraction property of equality. I'm going to subtract it from 9x on the right side because those are going to be my like terms that I can combine. We're left with 3 equals 9x minus 6x gives me 3x minus 12. Back to solving a two-step equation. I'm going to get rid of that extra term on the x side of the equation by adding 12. 3 plus 12 makes 15 equals 3x. Isolate x by dividing by our coefficient 3. 15 divided by 3 is 5. 5 equals x. Final answer, our solution. Number 7, negative 2x minus 9 equals 3 minus 21. So I always said I get rid of the smallest variable first. Negative 2 is smaller than an understood 1x. So I'm going to get rid of that negative 2x by adding 2x to both sides. I'm left with negative 9 equals, this was an understood 1x plus 2x makes 3x minus 21. Keep solving your two-step, add 21 to both sides. Negative 9 plus 21 is going to leave us with 12 equals 3x. Divide by the coefficient of 3. 12 divided by 3 is 4 equals x. Final answer. Last one, number 8. Negative x minus 8 equals negative 4x minus 23. I always get rid of the smallest variable. What's smaller, negative 1x or negative 4x? Negative 4x is smaller. So that'll give me a chance to add 4x and help make this problem more positive. On the left side, we're going to combine that negative 1x with the 4x to give us positive 3x minus 8 equals negative 23. And keep solving the two-step, add 8. 3x equals negative 15. Divide by 3, the coefficient. X equals negative 5. Final answer solution. I could plug it back into our equation. Now, I haven't shown this, so let's use it on this problem, actually. That would be a great example. So our original problem is a negative, then x, which I got negative 5. Look how tricky this looks. Minus 8 equals a negative 4 times negative 5 minus 23. Okay, now when you have variables on both sides, when I evaluate the left side, I should get the same number when I evaluate on the right side. Let's see, those two negatives are going to make a positive 5 minus 8. On the right side, the two negatives are going to make a positive, and we're multiplying to get 20 minus 23. Left side, 5 minus 8 is negative 3. Right side, 20 minus 23 is negative 3. Same thing equals same thing. So the solution was negative 5. It made the equation balanced and equal, so the equation was true. Okay, really interesting stuff there. So you can always check your answers. Let me label this was our check. And it did check out. So that's going to conclude our solving equations review, your first lesson. We went over the properties of equality. We looked at various examples of solving two-step equations. This is a good variety. I modeled it after Delta Math. You'll notice I do that for all of our notes. I kind of pull one of every type that I see occurring on Delta Math, and I make sure we go over it in our notes. So you should have an example there of any of the weird ones. And then lastly, we looked at solving equations with variables on both sides. And we'll go a step further in our next lesson, solving more equations. So beauty of this being a video, you can pause it, you can rewind it, you can watch it 500 more times. So wherever you have questions, you can go back and watch. And then you can always let me know if you have questions in class, and we can work on them together. So I will see y'all in class. Y'all have a great day.